All right, so this is a variable length subnet mask question. And so by definition, there should be different masks. Okay, in this question there was only one. It was a /22, 255.255.252.0. In this type of question with VLSM, there'll be at least two. And this was in the, again, this is the, on the web, you could have done this homework yourself. The answers were out there. The network's 129. 1.34.0/24. And what we ask for are 5 networks. The first network has to be at least 100 usable addresses. The second network needs to be 32 usable. The third needs to be 10, and the fourth and fifth need to have 5 addresses each. Be efficient with the addresses, meaning don't waste any. Don't make the networks too big. Make them just big enough to meet the requirements. And assume you can use the all zeros and all ones network, which really means CIDR is enabled. And the thing I want for each of those 5 subnets is the net, the mask, the broadcast, and the mask, I want it in slash notation. So those are the three questions that I need for all 5 subnets. And the 5 subnets is we need 1 times 100. We needed 1, I think it was 1. No, yeah, the second network needs to be 1 times 32. The third needs 10, thank you. And there was 2 at 5. All right, so we've already got our chart. What's the first thing? Draw the mask, thank you. /24. Very boring. There's our mask. What's our octet of interest? The 4th. Because it's the only place we have to play, right? And these are set. These first 3 octets, the ISP gave us 129.1.34 set in stone. I can't mess with those. So the only place left is the 4th octet. So this is the one we're worried about. We can't figure out our magic number yet, can we, though? All right, I mean, if we looked at the magic number, where does the split happen? Well, it happens here, so the magic number would be 256, right? 2 to the 8th. Because the network's one big network with 256 hosts on it right now. We haven't subnetted yet. So I've got to start the subnet process now. What I do is this is just best practice. You can actually go the other way. I don't recommend it, but you can. But I prefer, and I've always seen it done, is you start with the biggest. So I need 1 network with 100. So how many bits do I need to represent at least 100 hosts? Lots of quick answers, and they are all right. 7 bits. 2 to the 7th gives us 128 possible combinations. We always have to eliminate 2, 1 for the broadcast, 1 for the network. So there's there's 126 usable addresses. That meets my requirement, and it doesn't waste any. If I used all 8, well, I wouldn't be subnetting, would I? Right? I'd use that whole section, and we'd waste a bunch of addresses. Okay, so if I need 7 bits for hosts, this is the only network bit, right? So for the mask, it looks like that, doesn't it? And we need to use all 7 of those bits. So, easy point. In fact, these are the highest points, value points, as you get the mask right. What's our first mask in slash notation? Let's get that on paper. And we know the first 3 octets don't change. Dot 128. Dot 0. Remember, the first network is the all zeros network. Well, in this subnetting example, there's only 1 bit. It's either on or off. And the first network it's off, right? Isn't it always off? And if it's the network, isn't the host bits always all off? Versus the broadcast, all host bits are always all on. So this bit is off and the host bits all have to be off. It's 0. Yes?
So would it be incorrect? I mean, is another possibility to have it as 128?
That would be the second network.
Okay. So I couldn't start necessarily with 128, but...
Right, well, if I only have, I mean, no, if you started with 128, you'd go 128 up to 255 or 256 and you're done. Well, then you'd have to somehow backtrack and fill in the bottom. Hint, it always starts with 0. The first network in every one of the problems we've done has always been 0. The first network's, hint, always 0. Okay? Because the network portion is 0 and all the host portion is 0. So it's got to be a 0. So, I mean, the only exception, well, no, this isn't even an exception in the here's a network, go through and figure them out. The very first network you see me draw tonight was 0, and then 4 and 8, or what, I don't remember what the magic number was. I think it was 4. Okay, so I'm cooking. I've got a big chunk of this done. So this is net 1. And the broadcast, always don't forget. So the 128 is a number we need. It's the next network, isn't it? And if you look at it in binary, doesn't that make sense? The first one, the first network, it's all zeros. And we only get to play with this one little bit. We turn it on. What's that? 128. See how in binary it's clear? Ain't so clear in decimal. Okay, so the next network's 128. But we haven't figured out our magic number. And I guess on the first problem, I guess I didn't write it down. It was 128. But this is variable length subnet masking. They're not all going to be /25s. We've got this one done. Well, the broadcast, we're going to finish in a minute, so I won't check it. I like to do the broadcast after I do this next network. Well, we can do it. I'm going to write small here, 129.1.34. I'm going to write this one big, 127. That's not a slash, that's a 1. Okay, why? It's 1 less than the next network. Nothing changes here. It's the same process every time. Okay, so I've got that one out of the way, and I can fill the rest of this in, 129. Man, I'm getting points here, and I haven't even really been doing anything. But this is big points. This is the big points right here. But look at it. All I do is now I do the same problem again. I do the same exact problem over again. Which is, now I need a network with 32 hosts. How many bits do I need for 32? 6? You guys are getting too smart for me. This isn't enough. You always have to subtract 2 on the host. Not on networks, but on hosts you do. So I've got to go up to 64. So I have to add, how do we always do that? So our magic number is now 64. So what's the process? I add it to here, don't I? Add it to the last network. 128 plus 64. 192? And what does my mask look like? I skipped a step there, sorry, but 64 is 6 bits. So I need 6 bits for host. 1, 2, 3, 4, 5, 6. So these two are 1s now. What's my mask? And this is the next network. So you see how the mask kind of comes late? And then the broadcast also comes. So now the broadcast is 129.1.34.191. And I got my next network already set. Ready to roll. Okay, we got this one done. And heck, I got this one done now. So now I need one with 10 addresses on it. How many bits do I need for 10 addresses? 16. 16 minus 2 is 14. That's enough. If you went here, that's too little. If you went there, that's too many. 4. So our new magic number is 16. And our mask is 4. I need 4 bits, 1, 2, 3, 4. There's our new mask. 8, 16, 24, 25, 26, 27, 28. Notice how the number double jumped this time? Well, did you see how I went? We never had any networks we went from 2 to the 6th down to 2 to the 4th. We skipped this, and so we skipped a bit we didn't use. All right, I need to know my broadcast. How do I know my broadcast? I need to know the next network. What's my magic number? Oops, I didn't cross this one off. It's 16. 192 plus 16. Uh, 8. 208? Yeah. That's the next network. So what's my broadcast for this one? So this is net 1, 2, 3. What's my broadcast for network 3? 207. I'm not going to do this. Ditto, 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 dot 207. Okay. Now I need 2 with 5 hosts per subnet. How many bits do I need to represent 5? 3. Okay, and that gives us 8. So our new magic number is 8. And I need 3 bits is all. 1, 2, 3. So this one becomes part of the mask. So now my mask is 8, 16, 24, 25, 26, 27, 28, 29. And the broadcast, I need to know the next network. So what I need to do is add my magic number to this. Same pattern, doing the same thing, mechanical thing, over and over again. I add my magic number, which is 8. The next network is 216. Ditto, ditto, ditto. And so what's my broadcast? This, I didn't line these up very well, but this is for that one. Okay, what's my broadcast for this network? 215. Ditto, 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 dot 215. We're getting close. I got one of the 2. I get a half check for that one. Yes?
Could you explain why we need 3 bits if we only need 2 hosts?
Who said I only need 2 hosts?
2 networks.
I need 2 networks, 5 hosts.
Oh, okay.
right? The first number is always how many networks, and the second number is hosts. Is that good? Well, we got to create one more of these. So we could go through the same process, right? I need 5 hosts. That means I need 3 bits. That means I need 3 bits. Well, I just did this, right? Whenever I ask for more than 1, you get to kind of skip some steps. The magic number didn't change, right? I need 2 networks of the same size. So my magic number is still 8. My mask didn't change. /29. Well, and doesn't that make sense that it would be the same mask? It's the same size network. Okay, and now I know, guess what? I already knew my mask, or my broadcast. So the last step is I need to get my broadcast. I got my network, I got my mask, sorry, and now I need to get the broadcast address. What's the broadcast address? 1 less than the next network. Use your magic number for the last time. 8, 216 plus 8 is 224, right? Ditto, ditto, ditto. So it's 224, and actually I don't even want to put those dittos there, right? This is just me doing this so I know what the broadcast is, because we're not going to use this network right now. So it's the same broadcast dot 224 minus 1, 223. And there's net 5. And I really don't use this number. I just used it to calculate my broadcast. And did I need 5 networks, 2, 3, 4, 5, and I got one that will hold 100 addresses or more. I've got the second network will hold 32. The third will hold 10. The fourth and fifth will hold at least 5. They'll actually hold 6, won't they? It's 2 to the third, which is 8 minus 2 is 6. So we just waste 1 address on those networks, those last 2 networks. Full credit. Questions? Yes?
So if you were to go further and ask what the usable addresses in each of those ranges are, would we just subtract 1 from the broadcast and add 1 from the network? And we have everything.
So his question was what if I asked for the range of addresses? All right, the range of valid addresses. All you do, the range of addresses that are usable are, the only 2 we can't use are the all zeros, right, which means this network, and the all ones, which is the broadcast. Well, this is the all zeros, and all ones is the broadcast, right? So you would subtract, so the bottom of the range is the network plus 1. So for this network, the range would be .1 through .126, all right? Because the network all zeros and the broadcast all ones sandwich all the usable addresses are in between those 2. Good question. Any others? Yes?
I'm sorry, so
No, go ahead.
If the octet of interest in the VLSM cases is the third, would the last number always be .255 for each of the networks?
So his question is the octet of interest is the third octet, and we did one of these last time. And actually, the first one we did was the interest was in the third. The range is always going to look, the first network will always be 0.0 in that case, right? Because all bits are 0 in the third octet as well. And then the broadcast is always going to be something like 4.255 or 8.2, depending on our magic number, right? Let's say if our magic number is 128, then the broadcast would be 127, right? You got a minus 1.255. And if you just imagine, I made that point on the first problem, that the broadcast, all the host bits are on, right? All the host bits are on. And for the last octet, it's clearly 255, because that's all host bits. If the octet of interest is the third octet, then that means, by definition, the fourth octet are all host bits. And what's all host bits on? 255. Makes sense? And then the third octet, well, remember, that's a split. Some of it is host and some of it is network, so I can't make a blanket statement like that. But I can say 1 minus the magic number minus 1 is all the host bits are on. You could do it in binary and prove that, but that's my little trick, is I just take that magic number, you know, again, it's the magic number for the first one, right? And then we add 8 more, or whatever, and minus that is your broadcast. Clear as mud? Good. Yes?
So if someone came in later and decided that they wanted to use the last 5 bits for one more network, would that be possible?
Absolutely. This is why it's called, this is why you want to be efficient with your allocation of addresses, because, you know, we don't want to get into the same old bad habit we had, is, just, you know, whatever, make it easy, throw a bunch of addresses even though we don't need them. Because officially, I didn't have to stop at 216 for this last one. I could have gave it more hosts. But then later, that's why we keep on getting burned, is later, oh, I need one more subnet. Well, if I've already given it out, it's a major pain to renumber, do IP address renumbering. So leave this 216, or sorry, the next network would be 224. Leave this 224 network alone. Because we can use that whole range from 224 all the way up to 255, minus 1, as usable addresses for another project down the road.
And would that be a /27? Does the mask go backwards?
Let's do it. So if the next network is 224, what's it take to get to the end? We have to go to 256, right? What's 224 or 256 minus 224? 32. Okay? 32. You hit it on the head. It's exactly right. 32 is 5 bits. So I would need 5 bits. 1, 2, 3, 4, 5. So my mask, so ditto, 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 224. This is not on the quiz, by the way. But it's a good point. 224. What's my mask now?
So the important part.
And now I've used up the last of the addresses. And that's why you go in that very methodical order, right? Grabbing a chunk, grab the next chunk, grab the next chunk, and then whatever's left is conveniently at the end, instead of getting goofy and making it. Don't make this any harder on yourself than it already is, right? So by just doing it starting and just grabbing a chunk as you need it, then whatever's left, so yes, this is at 7. 127, I'm sorry, /27. Is your mask. And what do you think the broadcast would be? 255, right? Because the next network, we figured out our magic number was 32. 224 plus 32 is what? 256 minus 1 is what? 255. There's our last broadcast address. That's subnetting.